Hello, everyone. Welcome to First Online University, a global platform for all your education and growth related needs. In this lecture, we are going to continue with the chapter P block elements, and we are going to discuss group 13 elements only. And we will be doing boron hydrides in this lecture. Apart from that, the properties, structure, as well as uses of diborane. That's what we are going to discuss in this particular lecture. Before we begin, a piece of information for you. You can use the coupon codes Mission J or Mission NEET while you enroll at First Online University for Mission J or NEET in order to avail good discounts. Let's first begin with boron hydrides. Now, we've already discussed in brief and also in detail about boron. Let's now move on to our discussion on boron hydrides. Now, as is clear from the name, boron hydrides means boron and hydrogen present in the form of H minus. So when we talk about the binary compound of hydrogen of boron with hydrogen, we call it as boron hydrides, and we also know it by the name of borines. Now, these hydrides can be divided into two series. The first one is BnHN plus 4, which are known as nidoboranes, and BnHN plus 6, which are known as arachnoboranes. Okay, so nidoboranes, nido comes from the word nidus, Latin word nidus, which means nest. And arachno comes from the Latin word which means spider's web. Okay, so when we talk about firstly, the nidoboranes, that is BnHN plus 4, and then we will be comparing them with BnHN plus 6, that is arachnoboranes. Now, for instance, if I talk about nidoborane, the first example is B2H6. That means we have B2, that is N is 2, and N plus 4, that is 2 plus 4 will be 6. So B2H6 is an example of nidoborane. That is a diborane. If you talk about borane, borane is what? BH3. So 2 moles, a dimer of borane would be what? B2H6 only because it will be BH3 and BH3. So total it becomes B2H6. And B2H6, which is diborane, is also an example of nidoborane, that is BnHN plus 4. Next example is B5H9, that is pentaborane 9. Then B6H10, that is hexaborane 10, B8H12, octaborane 12, B10H14, that is decaborane 14. Next, we move on to BnHN plus 6, that is arachnoboranes. So, B4H10 is an example of it because here N is equal to 4 and 4 plus 6 is 10. So, B4H10, that is also known as tetraborane 10, is an example of arachnoborane. Similarly, B5H11, which is pentaborane 11. Similarly, B6H12, which is hexaborane 12. B8H14, octaborane 14, and B9H15, that is nonaborane 15. Now, make a note of the fact that boranes have gained importance as potential high energy fuels in view of their high heat of combustion. That is, when we burn them, a lot of heat of combustion is going to be released. So, when we are actually treating or heating, you can say boranes with oxygen, that is, they are undergoing combustion reaction, a lot of heat is liberated. And this heat is actually very useful because it has got high energy potential, which can be used in energy fuels. Okay, so this is how we can make use of the heat of combustion in, supplying energy to the fuels, right? So that is how we can say, that is why we can say boranes have gained a lot of importance these years. Now, these are better fuels than hydrocarbons because hydrocarbons release greenhouse gases, cause global warming and air pollution, but these diboranes, boranes, etc. do not. Then heat of combustion of diborane is much higher than that of ethane. So this is how we can compare. Another reason of comparison where we are going to compare our diboranes with hydrocarbons, that is say ethane. So here in terms of the heat of combustion also diborane is much higher. It has much higher heat of combustion. Now, when we talk about diborane in detail, the simplest boron hydride is diborane B2H6. It is prepared by treating boron tetrafluoride, that is BF3, with LiAlH4. Now, lithium aluminum hydride, LiAlH4, is a very good reducing agent. Why? Because it is capable of adding hydrogen in the form of hydride to a particular compound, and addition of hydrogen is nothing but reduction. So BF3 on treatment with LiAlH4 in the presence of diethyl ether, this is the reaction that is taking place, will give B2H6. That means from BF3, F is getting removed and we are getting hydrogen or hydride in its place, and that is where hydrogen is being given by lithium aluminum hydride to BF3. Therefore, it is acting as a reducing agent because it is reducing BF3 by adding hydrogen to it. Now, when we talk about the preparation of diborane, the first is laboratory method. The oxidation of sodium borohydride, NaBH4, that is again a very important reducing agent, with iodine. Now, the one which is a reducing agent will reduce the other compound, but itself gets oxidized. So the one that is capable of getting oxidized, its oxidation with iodine is what we are doing here. That is NaBH4 on reaction with I2 will give B2H6, NaI, and H2 is going to be liberated. So again, the reducing agent NaBH4 is actually getting oxidized to B2H6. The second is industrial method. So what we are doing is we are looking at the methods of preparation of B2H6. So the first method was the laboratory method. If we have to prepare B2H6 in the laboratory in small amounts, we make use of NaBH4. But if we have to prepare the diborane in large amounts, that is at the industrial level, we'll have to make use of the industrial method of preparation of diborane. So this is diborane is produced on an industrial scale by reaction of BF3 with sodium hydride, NaH. So here NaH is going to be acting as the reducing agent to replace fluoride with hydride. That is, when NaH is going to react with BF3, what we will get at 450 Kelvin is B2H6, that is diborane, and NaF is what we obtain as the side product, and we can balance this chemical equation. So sodium hydride with boron trifluoride gives diborane as the product. Now, based on this, let's have a look at few MCQs. B2H6 is closoborane, nidoborane, arachnoborane, or cladoborane. So we have discussed about nido and arachnoboranes, which are the important components of boranes. So out of that also, if we look at the formula, we see that since n is equal to 2 here, when we put n is equals to 2, then 2 plus 4 is what is giving me 6. So plus 4 means we are talking about nidoboranes. So option B is the correct answer. Next is, now this is where you have to predict X and Y products. If BF3 is going to be treated with lithium aluminum hydride in the presence of diethyl ether, that will give me a product X. And BF3 on treatment with sodium hydride is going to give me a product Y. Here we have to predict what are going to be the products X and Y. We have already seen that both these reactions with both these reagents, we are going to get diborane as the product. So option A is the correct answer, that is B2H6 and B2H6. Next question is B2H6 is an electron-rich compound, electron-deficient compound, electron surplus, or super electron-rich compound. See, when we talk about boron, being present as a dimer, then it is or in general also when we are talking about boron compounds, we have seen that the octet is incomplete and therefore it is an electron deficient compound. Option B is the correct answer. Next, we move on to the properties of diborane. So we've already discussed about what is diborane and what are the methods of preparation of diborane. Now we are going to move on to the properties of diborane, and then we'll be moving on to the uses of diborane. So when we talk about the properties, first of all, we need to talk about both the physical as well as the chemical properties, what it looks like, how it smells, what is the melting point or boiling point or whatever, right? These are all the physical properties. Then what all reactions can it undergo will be, under the chemical properties of diborane. So firstly, let us discuss the physical properties. So it's a colorless gas, okay? So that means it's in the gaseous form and it has got a very foul smell. It is stable at low temperatures in the absence of grease and moisture. At high temperature, it decomposes to give other hydrides of boron. Okay, so B2H6 is going to decompose to give other hydrides of boron. It is a dimer of BH3, we know, and it does not exist as a monomer. So this is the structure how it looks like. So we have two hydride bridges and two hydrides on the two borons each. It readily reacts with water to give boric acid, and H2 gas is going to be liberated. You can have a look at the reaction. So B2H6 plus 6H2O will give 2 moles of H3BO3, which is boric acid, and 6 moles of H2 is going to be liberated. Next is the physical state. So we have already seen that it is a gas. It's the gas. In the gaseous form it exists. It is colorless, but it is highly toxic at the same time, and it has got a boiling point of 180 Kelvin. Then we talk about its combustibility. It catches fire spontaneously upon exposure to air. So it is going to burn in oxygen involving an enormous amount of heat. So B2H6 plus O2 will give B2O3 and water as the byproduct. And here heat of combustion is minus 1976 kilojoules per mole. So you can see a very large amount of heat is going to be liberated in this reaction. Next is hydrolysis. So diborane is going to be readily hydrolyzed by water, forming boric acid. We have already discussed this reaction. Next is reaction with Lewis bases. Now, because diborane we have already seen is electron deficient, that means it is a Lewis acid. So it is going to react with Lewis bases. That is, diborane undergoes cleavage reactions with Lewis bases to form borane adducts. That is, B2H6 will react with, say, trimethyl ammonia, which is a Lewis base, to give what we have as this borane adduct. Now, what do we mean by adduct? Adduct is where we have a positive and a negatively charged cation and anion together, joined together, or you can say bonded together through a coordinate covalent bond. That is, the lone pair is going to be donated from the electron rich species to the electron deficient species, and we have this adduct being formed. Okay. Similarly, B2H6 on reaction with carbon monoxide will again form an adduct where the carbon is going to be the positive part and BH3 boron will be the negative part again. Okay, and we can balance this chemical equation. Next, we move on to the reaction with ammonia. Now, very similar to the reactions that we have seen with other Lewis bases, it combines with ammonia also to form an addition product. That is, B2H6 plus ammonia will give B2H6 dot 2NH3. That is diammonate diborane. Or we can also write it as BH2NH3 whole twice, BH plus and BH4 minus. That is in the form of the adduct that we have seen, because ammonia itself is electron rich and a Lewis base. So just as we have seen the reactions of diborane with other Lewis bases, similar way it's going to react with ammonia also to form this adduct, as we can see. Okay. And when this adduct is going to be heated at 473 Kelvin, what we get is B3N3H6 plus H2 gas is going to be liberated. Now, what is B3N3H6? A very important compound of boron, that is borazole. Now, this has structure very similar to that of benzene. What is benzene? C6H6. Right? So what we have is 1, 2, 3, 4, 5, 6 carbon atoms, and each of the carbon atoms have one hydrogen atoms. Now what you have to do is you have to replace 3, 1, 2, 3 carbon with boron, alternate ones, and the rest of the 3 carbons with nitrogen. And now you put one hydrogen each to boron and nitrogen. This is nothing but borazole, which is known as inorganic benzene. Okay. The structure of borazole is very similar to that of benzene, and it is known as inorganic benzene. So you can look at the structure of it. So each of the boron and nitrogen atoms has one hydrogen atom, and there is going to be a conjugate double bonds that are going to exist, just as we know is the case with benzene. That is why we call it as inorganic benzene. So note that borazole is isostructural as well as isoelectronic with benzene. So this is a very important question that can be directly asked, both isostructural as well as isoelectronic. Next is a reaction with metal hydrides. So several metal hydrides are going to react with diborane to form tetrahydridoborates or borohydrides. That is, if we have, say, take the example of any metal hydride, general example, say MH, okay, that's one general metal hydride that we are taking. Now, when this is going to react with B2H6, that is diborane, in the presence of diethyl ether, what we get is the MH bond is cleaved, where metal is the positive part, hydrogen is the negative part because it is existing in the form of hydride. What we get is MBH4. So M plus BH4 minus. That's like metal hydride plus diborane is going to give me metal borohydride. Next is reaction with, okay, in the reaction with metal hydride, we can have a look at a particular example. So lithium hydride will react with B2H6 in the presence of diethyl ether to give lithium borohydride, Li plus BH4 minus. Similarly, we can have the reaction of sodium hydride reacting with B2H6 in the presence of diethyl ether to form sodium borohydride, NaBH4. We have studied this a lot many times. Now, diborane is going to give H2 with which of the following? So, if we look at the reactions here, B2H6 plus water is going to give me boric acid plus H2. So, it's going to liberate H2 when it reacts with water. Next, we talk about its reaction with KOH, aqueous KOH. Therefore, we have water and KOH together to give KBO2 plus H2 is going to be liberated as the side product. So, if we see with water as well as with KOH as well as with ammonia, it is going to liberate H2. Next question is, so if B2H6 is going to react with trimethyl ammonia, which is a Lewis base, or simply with ammonia, the products X and Y are going to be formed and we have to predict the products. So if we see here, in the first case, the product is going to be NCH3 whole thrice, and from nitrogen to boron, we will have the electrons being donated, right? But when we talk about its reaction with ammonia at 473 Kelvin, what we get is borazole, that is B3N3H6. So option C is going to be the correct answer to this question. Next question is lithium hydride acts as. So lithium hydride is nothing but metal hydride when reacting with diborane is going to give metal borohydride. So here the metal hydride is actually acting as a reducing agent because it is giving hydrogen to boron. In lithium hydride, the negatively charged species is very simple. It's hydrogen which is negatively charged, present as H minus. So option D is the correct answer. Next, we move on to the structure as well as the uses of diborane. So we have already seen the structure of diborane is very interesting, and each boron atom has 3 valence electrons for sharing. So when we talk about boron, boron is 1s2 2s2 2p1 configuration. That is the so if we look at the electronic configuration, that is 1s has 2 electrons, 2s has 2 electrons, and 2p has 1 electron. What will happen is 1 electron from 2s is going to move to one of the empty subshells of 2p, so that now we have 1s2, 2s1 and 2p2. This is actually making it sp3 hybridized, right? So if we assume that each boron atom forms 3 covalent bonds with 3 hydrogen atoms, then there will be no electrons left with boron atom for sharing with other boron atom. That means, how are we actually going to connect these 2 boron atoms? So no electron for BB bond formation available. Therefore, by Raman and NMR studies, so we perform spectroscopy in order to find out what its structure is actually existing as. So by Raman spectroscopy and nuclear magnetic resonance spectroscopy, it is confirmed that the 4 hydrogens of diborane are of one type and the remaining 2 hydrogens are of other type. Now, if we look at this structure, 1, 2 and 3, 4, these 4 hydrogens are of one type. These 2 hydrogens are of other type because they are the bridging hydrogens. So 4 terminal hydrogen atoms and 2 boron atoms lie in one plane. 1 hydrogen, so we have 2 boron atoms and 4 hydrogen atoms in one plane. 1 hydrogen is above the plane, the other hydrogen is below the plane, and these 2 are called the bridging hydrogen atoms. As you can see here, HB is the bridging hydrogen atoms and HT are the terminal hydrogen atoms. The four terminal boron hydrogen bonds are regular, and they are regular means they are two centered, two electrons bonds. That is, there are two centers means boron hydrogen two centers and one electron from each. So two center, two hydrogen. While when we talk about the two bridging hydrogens, these are different because here we have three centers: boron hydrogen boron, boron hydrogen boron. So there are three centers and there are going to be two electrons on these three centers. Okay. So when we have boron, we look at boron having three orbitals that are available having one electron each, and boron is again having another boron will have three electrons each, and now they are going to form bonds with four terminal hydrogens. And if we look carefully, the middle two hydrogens are actually donating only. So overall, there are going to be just two electrons present over three atoms. Okay. So two center two electron bonds for the terminal boron hydrogen bonds and three center two electron bonds for the bridging ones. These three center two electron bonds are also known as the tau bonds or the banana bonds. Very, very important. Boron sp3 hybridized, hydrogen s hybridized, then again a boron sp3 hybridized. So sp3s sp3 forming a banana shape. So they are known as banana bonds. Methylation of B2H6 is going to give Me4B2H2. Lastly, we move on to the uses of diborane. It is used as a catalyst in polymerization reactions. Then it is used as a reducing agent in organic reactions. It is also used for making high energy fuels and propellants. It is used for preparing hydrocarbons, alcohols, ketones, and acids through hydroboration method. Let's have a look at few MCQs quickly. What is the hybridization of boron and diborane? We have already seen that it is sp3 hybridized. So option C is the correct answer. Next is number of three-centered two-electron bonds in diborane. We have seen that there are two such bonds which are banana bonds. So option A is the correct answer. The bond angle between boron and bridging hydrogens is, we have already seen that the bond angle is 97 degrees. So you have to remember this also. So this is all about diborane that we had to discuss. You can subscribe to our YouTube channel for joining YouTube live classes for best NEET or JEE coaching. You can also download the First Online University mobile app through Google Play Store or App Store for continuous learning through your smartphones. Keep learning with First Online University, a team of millions of learners and educators worldwide.